Hello JCE Connect. I welcome you all for this particular lecture. In this particular lecture, I'll be solving a problems on specific energy. So in previous lecture, we have been seen uh, the derivations for critical depth, critical velocity, and condition for minimum specific energy and condition for maximum discharge. So in this particular lecture, we'll see the few problems on specific energy. So this is the first problem I'm solving here. That is, the water is flowing through a rectangular channel of 4 meter width at a rate of 12 meter cube per second. The depth of water in a channel is 1.6 meter. Calculate the specific energy head, critical depth, and minimum specific energy head. State whether the flow is subcritical or supercritical. So this is a problem given. So here the rectangular channel is given. The rectangular channel of width 4 meter. Here the written the given data width is given 4 meter. Depth of flow y is given 1.6 meter and q is given 12 meter cube per second. So what is needs to be find here is specific energy head. We need to calculate the critical depth of flow in a rectangular channel to be calculated, then the minimum specific energy and what is the type of flow at the end we need to mention here. So this is the rectangular channel given. So here the width is given as well as the depth of flow is given. For this given width and depth of flow, we need to calculate what is the specific energy head, critical depth, and minimum specific energy. So here we need to calculate the critical depth, that is yc is equal to, we know the formula, q square divided by g raised to 1 by 3, and critical velocity can be written as root of g yc. This is critical velocity, and minimum specific energy formula we are having, that is 3 by 2 yc. So these are the formulas we are having with us. First we need to calculate what is the area of flow. Area of flow in a channel, that is A equal to B into Y. We get 4 into 1.6, then we get, if you multiply 4 into 1.6, we get 6.4 meter square. Then calculate average velocity V equal to Q by A. Q by A. Here Q is given, that is 12 divided by 6.4. We get average velocity as 1.875 meter per second. Then specific energy head, E can be written as, then calculate specific energy head, that is E can be written as y plus v square by 2g. So this can also be calling as specific energy head. Then substitute y and v here. So when you substitute y here, y is given as 1.6 plus 1.876, that is velocity here, 1.875 square divided by 2 into 9.81, then we get 1.779 meter. Then the discharge per unit width can be calculated as discharge per unit width, because we want this value, discharge per unit width, that is Q, that is Q equal to Q by B. Q is given 12, divided width is 4, we get 3 meter square per second. So this is required here. This is discharge per unit width, because to calculate the critical depth, we need q, small q, that is discharge per unit width. So discharge per unit width will be this one, q by b, 3 meter square per second. Now calculate the critical depth. Yc will be cube root of q square by g. Then when you substitute the value here, you will get 0.972 meter. Then minimum specific energy in terms of critical depth, minimum specific energy, that is E minimum. We know the formula for E minimum in terms of critical depth. So substitute here 0.972. What do we get? We get 1.458 meter. Okay, this is the answer. And one more question asked here. Here state whether the flow is subcritical or supercritical. So we have to classify this flow based on the Froude number as well as. So we know that in a channel, this is the flow depth. If suppose this flow depth is, say, critical depth, if the depth of flow in a channel, just way to compare this critical depth flow. So here the critical depth we have obtained, how much we have obtained? We have obtained 0.972 meter critical depth. But the depth of flow in a channel is how much? The depth of flow in a channel, this one. This is the depth of flow in a channel. The depth of flow in a channel y is 1.6 meter. So here y is greater than yc, means depth of flow in a channel section is greater than critical depth. This is the critical depth, but the depth of flow in a channel is already greater than critical depth. Then the flow can be classified as, means when depth of flow becomes greater than critical depth, then the Froude number will be less than 1. Okay, so when the Froude number becomes less than 1, so we are having a Froude number equation is equal to v divided by root of y g yc. If we substitute in this equation, we get a Froude number. The Froude number we get here as velocity. Also we are having velocity is 1.875 divided by root of 9.81 into 0.972. So here we are getting a Froude number 0.615. Even you can calculate Froude number, and based on that you can decide what type of flow it is, or based on this depth of flow, just to compare this depth of flow with the critical depth, then you can decide which type of flow it is. Since the Froude number here we are getting less than 1, or the depth of flow in a channel is more than the critical depth, the flow is subcritical. Flow is subcritical. This is the answer. Next. So we have calculated specific energy head. depth, critical depth, minimum specific energy. Then also we are classified a type of fluid.